And welcome back to this series of Let's Learn C Programming on channel Things Simplified. Please like, share, subscribe and press the bell icon to get notifications of next video. If you encounter any problem, if you have any doubt, please mention it in the comment section. Now, today we will have a look at variables and their scope in C programming. Okay, right. So, in C programming, the scope of a variable defines where it can be accessed within the code. I will repeat, the scope of a variable defines where it can be accessed within the code. There are two main scopes. One is global variables. These are declared outside any function and they can be accessed from any part of the program. We will write it down here so that it will be easier for you to understand. Variables. One is global variable and another is local variable. Local variable are declared inside a function. Listen to this carefully. Local variables are declared inside a function and can be only accessed within that function only. These variables are not visible, are not accessible outside the functions. Once a function is invoked, all the local variables are initialized. Right? Now, there is also a third category which is called as a static variables. Static variables. Static variable in C is a local variable, okay, that retains its value between function calls. At any more times you call the function, the value of the static variable isn't initialized. Only the first time you run a program, the static variables are initialized, and then whatever times you may call the function, those static variables are not initialized. They will retain their value of the previous call. Okay, so how to define it? Define it by using as a static keyword. Like for example, I will show you one example. Include stdio.h. These are all standard header files required. Now we will say we will define one function. Okay, this function will not return anything. It's a void function. We'll say counter. Okay. Now we will declare a static variable. Static, we have to define the type of the variable, integer and count. Count is a integer variable. It will be better if I define define it as a I count, so that by looking at this variable we can know whether it is a integer, float, character, static variable, right? Now here we will increment this I count plus plus, right, and we will print it here, so that we will check multiple times how it works. Printf static variable I count is equal to %d \n for next line, comma here, and the variable name I count, right? So according to the definition, static, this int I count will be declared only once and initialized only once. even if there is a the initialization statement as I count is equal to 0, but still first time only this will get executed, and next time onward this will not get executed, only it will retain, it will store this value of I count. Now let us call this from main function. Now just I will call this function counter. First time it should print, see here the first time the I count will become 0, so it will increment here in this line, it will increment, and here it will print the value of I count, right. So the first call to this function will print static variable I count is equal to 1. Second invocation, when I call this counter function second time, it will print 2. Let us check counter. Okay, 2 times I am executing this. Now we will compile and check. We will have a return 0 here. It's an int main function, return 0, right. So we will save this file, compile it and check it. GCC variables .c dash o variables. Right? Yes. So no syntactical errors. We will execute and check variables. Right? So static, first time it printed static variable count is equal to 1. Second time I count becomes 2. Third time it will become 3, and so on and so forth. This is an example of how to observe that the static variable is declared only once, and it will retain its value throughout the execution of the program. Whatever number of times you may call this, it will maintain as it is till the end of the program. Variables in C have several uses, including variable retention, which we saw now. It will retain their values between function calls. It can be useful in various scenarios, such as counters are to remember previous states of what happened last. Data hiding. Static variables are only accessible within the file they are declared in. Like this, now the variable static I count will be accessible only in this variables.c. This is the C program. Anywhere within this C program, this will be accessed. Okay, so the third is memory efficiency. Static variables are stored in the data segment of memory. Okay, when a variable is frequently used in a function. Then initialization only once. Okay, which we saw now. Remember, while static variables have their uses, they should be used judiciously to avoid potential issues within the code, because we want the code to be of nature readability and maintainability, right. We will have a look at another type of variable, global variables. Global variables in C are variables declared outside of any function, right. See, now here we have declared one function and in function here. So outside of these functions, we have to define variables which will be treated as global variables. They can be accessed from any part of the program, similar as static ones, right. But they will not return their values as static. Okay. Now let us have a look at one example of a global variable. Let us define a global variable here, that is before any function, right. It is an int. See, global function is equal to 0. We are initializing it global variable, right. So now what we'll do is we will write another function which will increment this global 1 variable, right? Void increment global variable. Here in this case only, there is no need of declaring parameters for this function. What it will do is only increment that global variable by 1 and keep going, right? So here now no need of defining an integer here and then getting the parameters, adding 1 to it and returning it, because since it is a global variable, it can be directly accessed here. Global 1 is equal to plus plus, okay, global plus plus. Now we will print and check. Printf global 1 is %d \en comma global 1, right? Yes. Now when I call this function increase global, initially the value of global is 0 and is defined as a global variable. Now here in increment global variable, we need not define another variable, add 1 to this and return it back, okay. So now let us check here. Let us call this function increment global, right? It will print 1. Let us check now. We have to compile it again, run it. See, global 1 is equal to 1, right? It was 0 here, previously it was 0 here, it incremented as 1. Now what if I call this function again here, just like we checked with the counter static variable. Let us check this function also, how it behaves, whether this global 1 variable is initialized to 0 and again it will show as 1 or it will show as 2, right? Again compile, again variables, right? Global 1 is equal to 1 first time it is called, global 1 is equal to 2 second time it is called. So this also retains its value, since all the global variables they will be initialized when we run the program. For the first time when we run the program, it will be initialized, and throughout the running of the life of the program it will retain its value, right?
Thanks for watching. If you found this video useful and informative, make sure to like the video, to show your support. Leave a comment below to share your thoughts and ask questions. Subscribe to our channel for more valuable content. Hit the bell icon to never miss an update. Share this video with friends who might need it. If you encountered any issues or have any problems, please let me know in the comment section. I am here to help.